untuk masa hadapan sebenarnya biodiesel ni adalah kita punya support untuk industri dalam minyak lah. Kita campur diesel tu dengan minyak yang kita olah untuk campurkan dia diesel. Itu yang dinamakan biodiesel lah kan. Macam kalau awak tengok dalam kat stesen minyak ada yang minyak di 15 ke B10 tu kan, B10 apa semua tu. Tu dia campuran dengan diesel. Jadi dalam industri sekarang ni kita tengok minyak diesel untuk kita gunakan dalam kenderaan lah kebanyakannya kan. Dan sekarang ni kita kita dah menghadapi satu situasi mana kita banyak guna kenderaan elektrik. Itu mungkin cabaran kepada industri biodiesel lah kan. Mungkin orang satu biodiesel ni mungkin dia bersih, kita nak dapatkan alam sekitar yang bersih. Tapi bila dah ada kita guna kenderaan elektrik pun dia lagi lagi bersih lah kan, lagi efektif lah. Ada gunakan minyak apa semua. Situlah kita punya cabaran lah kan. Mungkin dalam industri perkilangan mungkin akan menggunakan lagi lah biodiesel. Industri peladangan tu mungkin akan guna. Tu dah nak ambil gambar tu.
Barangkali apa perbezaan terhadap environmental impact antara biodiesel dengan diesel reactor? Okey. Itu master saya punya projek master. Okey, dia punya emission dia biodiesel lagi baik berbanding dengan diesel reactor. Masa saya buat research tu, saya buat minyak biodiesel campur dengan air. Dia punya NOx dia lagi turun berbanding dengan diesel reactor. Kalau biodiesel dengan diesel, NOx-nya baik daripada diesel lagi baik. Nitrogen oxide dah tengok. Kata saya lah, tak maaf kalau salah. Dia hasil dapat emission ni, dia ada macam-macam gas. Ada CO2, ada macam-macam gas. Yang saya target NOx je. Dia akan dropkan NOx. NOx tu kalau dia bahaya pada environment dan juga kesihatan. Itu je. Itu yang saya faham lah. Yang saya faham juga. Biodiesel lebih baik. Tapi dia punya, dari segi dia punya kecekapan enjin, diesel lagi bagus. Dia ada pro and kontra. Ada baik, ada keburukan juga, ada kelemahan juga. Ada kebaikan.
Ada pendapat tuan, biodiesel ni pada satu hari nanti akan lebih advance daripada diesel.
InsyaAllah, kemungkinan. Sekarang pun dah macam teknologi berlaku. Ada hidrogen, ada apa, kalau kenderaan gunakan elektrik, kan. Sebenarnya tengok bergantung pada revolusi keadaan lah, industri, yang macam mana. Saya rasa, bahan bakar ni, diesel makin lama dia makin habis. Kan? Tapi kalau 100% biodiesel pun tak boleh juga. Dia tak boleh jadi. Mungkin ada tambahan-tambahan lagi chemical yang perlu ada lah. Itu saya tak faham kalau chemical. Okey, lagi. Ada salah lagi?
Balik lens dia bukan. Bahan bakar dia dah.
Bahan bakar? Okey. Plan ni sebenarnya bukan operasi biodiesel tau. Just untuk PNP saja. Kalau betul-betul biodiesel, awak semua termasuk saya tak boleh masuk. Dia punya safety agak tinggi sebab dia ada melibatkan metanol, chemical, bahaya. Metanol ni agak bahaya. Apa share kat internet, dia macam-macam efek pada kesihatan, pada environment. Kalau operasi pun menggunakan equipment PPE yang proper lah. Jadi kalau untuk PNP, just yang ada minyak biasa tu. Minyak biasa, minyak masak tu. Campur dengan air, waktu kita circulate, kita buat heating process, bagainya tu je. Bukannya pure biodiesel kan. Kalau tak memang susah. Memang complicated dia punya content. Okey, itu je. Kalau sekarang ni kalau awak nak buat lawatan ni baguslah untuk knowledge. Awak baca thermodynamics kan? Thermodynamics tahu kan apa tu thermodynamics? Suhu yang bergerak daripada panas sejuk ke panas. Itu boiler kan menghasilkan steam. Awak belajar macam boiler kan? Itu boiler. Dia supply steam betul.
Begitu panaskan.
Yes, dalam vessel tu. Dia nak panaskan benda tu.
Ada mesin macam radiator tu untuk cooling.
Cooling itu cooling tower. Cooling tower tu radiator dengan heat exchanger. Dia ada banyak konten-konten. Biasanya kalau student BDJ atau BDG, kita kena test piping dulu. Kena kenal pasti untuk apa. Faham? Kalau untuk awal sekarang ni, masa level diploma, untuk knowledge pun dah tak okey lah. Heat transfer daripada cooling tower boleh jadi heat transfer, pH changer, boiler dan sebagainya lah. Macam ni suhu pun sama. Tadi pagi panas, sekarang hujan, humidity berubah. Itu thermodynamics juga. Faham? Okey. Okey, baik. Pula banyak.
Hello everyone. Today, my group, Group 6, which consists of me, Sham Sundar, Daniel Kaujunza, Shirong, and Dharaneshwaran, would like to present to you on our academic visit to Biodiesel plant.
Hi, my name is Dharaneshwaran and today I'll be talking about the introduction, vision and mission. This biodiesel plant converts waste cooking oil into clean, renewable fuel through an integrated system of reactors, boilers, and purification equipment. It showcases efficient thermodynamics processes and sustainable solutions that reduce pollution and support greener energy production. Vision to lead the transition toward renewable and sustainable energy through innovative biodiesel production technologies. Mission to provide accessible, efficient, and sustainable energy solutions by transforming waste resources into high quality biodiesel, promoting environmental stewardship and technological advancement.
My name is Daniel Kaujunza, and reference number is XL2240942. So now let's look at the plant overview. So the FKMP Biodiesel plant is an evaluate platform for the study and research purpose into the sustainable energy solutions. So now we got several global certification of the biodiesel industry. First, environmental friendly. So as we know, biodiesel is a clean burning alternative fuel and is essentially free of sulfur and aromatics. Next, sustainable alternative to petroleum-based diesel. So biodiesel is produced from renewable resources like palm oil and waste cooking oil. It is considered a vital fuel source due to its reliability and availability. Next, biodegradable and non-toxic. So biodiesel is naturally biodegradable and non-toxic. And lastly, reduce environmental pollution. So the use of biodiesel can mitigate the negative effects produced by non-renewable fossil fuel combustion and reduce the environmental risk from improper waste oil disposal, which may include CO2 emissions. Now let's look at the core capabilities of FKMP biodiesel plant. First, function and capacity. So the primary function is to convert the feedstock into fuel-grade biodiesel, and is designed to produce 1 metric ton of biodiesel per batch. And it utilizes a modular batch technology for operational flexibility, and the final product is planned for the use as fuel for university vehicles and for produce heating. Next, facilities and components. So the process consists of two modules, which is CPU of pretreatment and refining and separating. And the overall site includes a control and utility system, cooling tower, and storage tanks. Lastly, research focus area. So the biodiesel plant allows for process optimization, which enable the study of PID control systems, and is also used for sketch-up and environmental studies, including the wastewater treatment analysis. And most importantly, is allow the study of production of biodiesel. Now, let us connect the physical plant components to the fundamental principles of thermodynamics. So let's look at the energy conversion. So we got two examples, which is reactors and boiler. So reactors convert the chemical energy in the oil into usable fuel energy in the biodiesel. So and boiler generate the thermal energy needed to drive all high temperature chemical process. Next, heat transfer and control. So we got heat exchanger and vacuum pump. For heat exchanger, it used to manage the heat throughout the process and facilitate the cooling operating through thermal equilibrium to maximize the process efficiency. And its function using the cold water to cooling down the hot oil. So vacuum pump is used in treatment and purification to manipulate the pressure for effective material removal. And is also used to pump the hot oil from the base of the plant to the top of the plant. Next, process optimization. So we got two examples, PID controller and pressure and temperature gauge. So for PID controller, it controls the overall system of biodiesel plant. And for pressure and temperature gauge, it collect and transfer the pressure and temperature data to the PID controller to be manipulated. And lastly, the system efficiency. So we got pneumatic actuator. So pneumatic actuator serve as a manual backup control to adjust the flow of the hot oil to the reactor.
Now, we're moving to equipment and processes, which first starts with feedstock pre-treatment system. The process involves acid esterification, which the equipment used is stainless steel pre-treatment vessel SS304 with a mechanical agitator, a key component in producing a mixture. The function is by using acid esterification, which is sulfuric acid and methanol, to lower the acidity of the waste cooking oil. This prevents soap formation or saponification during the main reaction. Second is heating source, steam generation. Equipment used is a fire tube industrial boiler. Function is to burn fuel to generate high pressure steam with approximately 150 psi. This provides the thermal energy required to heat the reactor to 60 degrees Celsius via insulated piping system which runs throughout the plant. Now, we're moving on to the main reaction, which is trans-esterification, which the equipment used is a 1 metric ton stirred tank reactor. Its function is to mix oil, methanol, and catalyst for 1 hour at 60 degrees Celsius. This chemically converts the oil into biodiesel. Next is chemical recovery, which uses methanol recovery column, and its function is to heat the mixture for vaporization and captures excess methanol to recover expensive solvent and ensure safety. Now, for the fifth process, which is phase separation. The equipment used in the process is a gravity settling tank with a conical bottom. This allows the mixture to sit undisturbed and ensures that heavy glycerol sinks to the bottom while lighter biodiesel floats to the top. Next is a purification process, which involves washing and drying. The equipment used is a washing column and vacuum flash evaporator. Their function is to wash the fuel with warm water, then uses a vacuum to flash evaporate the existing moisture. This removes residual soap and impurities, which ensure the water content is less than 0.05%. Now, moving on to process 7, which involves cooling system or heat injection. The equipment used is an air-cooled heat exchanger, much like the ones you find in your car's radiator, but even bigger. This uses electric fans to force air over thin tubes carrying hot fluids. These transfer heat to the atmosphere to cool the processed water in a loop. 8 is the automation and control. The equipment they use is a SCADA system and a pneumatic butterfly valve. The function is to have a centralized computer monitoring of the pressure and temperature of the running system in the plant. It automatically opens and closes valves to regulate flow and prevent overheating. Now, for the ninth process, which is fluid transfer, the equipment they use is centrifugal pump. This is how they move all the liquids throughout the whole system. It acts as a high durability pump designed for viscous fluids. This pump moves the oil, methanol, and biodiesel between different vessels. It contains AC electric induction motor, secondly, which is coupling and guard, and the third is the pump root, which is colored green. Lastly, we're going to talk about the most important aspect of the whole process, which is safety and environmental consideration. Operational safety measure, which includes thermal protection, remote monitoring, pressure management, and chemical safety. Now, today, another also important aspect of this whole process, which is environmental impact and sustainability. Waste to energy. This plant consumes waste cooking oil from university cafeterias. Second, it uses chemical recycling. This distillation unit recovers up to 90% of the unreacted methanol, which significantly reduces the hazardous chemical waste. Carbon reduction. It produces biodiesel B100, which is a carbon neutral fuel with near zero sulfur content, reducing acid rain emission compared to petrol diesel.
Now, let's dive into the challenges that were faced by this plant and the innovations made to overcome these problems. The first challenge faced is about the site unsuitability. The initial site was unsuitable. They found fundamental problems related to maintenance, safety, and future expansion. This meant they had to make the critical decision to abandon the location and move to an entirely new site. The second problem faced was the rigid layout constraints inside the old structure. Designing that created problems like a severe lack of space, difficulty interpreting hazardous area, and a structure that was simply too inflexible for the constraints R&D modification they required. And finally, they had to address the inflexibility of using a continuous production flow. While standard for commercial plants, it would have severely limited their research goals, making it hard to quickly switch feedstock, test new catalysts, or perform the process modifications necessary for a dynamic research environment. To address those challenges, they've implemented three innovations. Firstly, the solution to unsuitable building was strategic site relocation. They've moved the plant to a new, dedicated building, immediately solving all the critical structural, safety, and maintenance accessibility issues identified at the previous location. Secondly, they've adopted a modular plant design. The facility is structured into two distinct modules, pre-treatment and refining or separating. This immediately simplifies construction, making operation clearer, and is ideal for future revamping and modifications for R&D. Finally, they solve the inflexibility issue with flexible batch operation. They now use a 1 metric ton batch process, which provides maximum operational flexibility. This enables them to test various raw materials and new processes without the constraints of interrupting a continuous flow. Besides the structural issues, they face operational challenges related to materials and process technology. Challenge number 4 was ensuring feedstock acquisition and managing cost risk. The risk was relying on non local or expensive oil, which would have undermined the project's long term sustainability and economic feasibility. They needed a stable, cost effective, and abundant supply. The fifth was the issue of low quality feedstock processing. Their primary source, crude palm oil or CPO, contains high free fatty acids, making it unsuitable for a simple one-step trans esterification. This demanded a robust multi-stage reaction system to meet international fuel quality standards. Finally, they had the challenge of environmental and safety compliance. The process generates waste products, specifically accessing methanol and contaminated water. The challenge was designing a simple to safely handle these outputs, reducing raw material losses, and fully complying with all environmental regulations. To address the challenges of feedstock cost, quality, and compliance, they've implemented three innovations. The answer to the cost risk challenge is a sustainable feedstock focus. They've utilized abundant local crude palm oil (CPO), which leverages Malaysia's resources and aligns perfectly with the national policy of renewable energy as a fifth fuel. To handle the low quality CPO, they utilize a robust two-step reaction process. This involves both esterification and trans-esterification, ensuring the final product is a high-quality, fuel-grade biodiesel that meets strict EN 14214 standards. Finally, they solve the compliance challenge with robust resource and waste management. That their design includes essential system for methanol recovery or cost-effective reuse, and crucially, for treating all wastewater from the process before disposal, ensuring full environmental compliance. The seventh challenge that was faced by them is the gap in practical training. Without a real industry standard plant, students and researchers could not effectively test theoretical models, gather necessary kinetic and scale up data, or gain essential practical experience on industrial scale equipment. The final challenge was avoiding manual operational control. Relying purely on manual input would have led to inconsistent process parameters like temperature, pressure, and flow, making it virtually impossible to collect accurate data for research and ensure precise control over the complex reactions. To address the training gap, the pilot plant now acts as a scaled up model of a commercial facility. This provides an essential platform for teaching, testing catalysts, gathering kinetic data, and solving real scale up problems. Finally, they solve the control issue with a modern SCADA control system. This supervisory control and data acquisition system ensures precise control, monitoring, and automated data logging, making it possible to gather the accurate research data that was previously impossible.
And now the conclusion. In conclusion, the biodiesel plants demonstrates how waste cooking oil can be efficiently converted into renewable fuel through well-integrated thermodynamic and chemical processes. The visit provided valuable exposure to real industrial equipment, process control, and safety systems used in sustainable energy production. Overall, the plant highlights the importance of renewable fuel in reducing environmental impact while offering practical insight into modern engineering application.